You're welcome to our third webinar in our series of Superhome webinars. And today we're talking about ventilation, super ventilation. And I have Marcus with me here from Moisture Master, who I'll hand over to shortly. But I was just going to talk initially a little bit about why we need to ventilate and the sort of importance of incorporating ventilation from the early stages of the design. So, a lot of people have probably heard about ventilation being a good thing and that we should be ventilating our homes, but not necessarily understanding the ins and outs of it. And this, just looking at the list of 60 or so people that are tuning in today, there's a lot of designers and even people from MB and councils and things. So, but there'll be also just homeowners. So we're going to go back to basics and talk about from sort of the occupant's point of view, why ventilation is important. And it's not always obvious because, air is invisible. So might just switch over to the presentation slides. I'm a designer. My name's Bob Burnett, and I'm one of the founders of the Superhome movement. My business is Bob Burnett Architecture. And we've really learnt through Marcus and others the importance of incorporating ventilation from the very early design stages and really had to become not an expert, but just aware of the key requirements. And even when thinking about the layout of the home or even the orientation and then the form of the home, how we're going to run ducts through the home so that we can achieve adequate ventilation. And a lot of the time it isn't thought about until it's too late, and then it becomes a real challenge. So Superhome movement, we're all about sharing ideas, and we're a charitable trust. So where everything is openly shared freely, and we're just wanting to make sure that everybody is aware of where the building code sits and what's missing from the building code. And ventilation is a classic example of something that is not really provided for in the building code, and we'll touch on that building code aspect further on. So we're a group of industry practitioners, designers, builders, subbies, suppliers who understand the importance of building beyond code and the importance for our health. And these are some of the people involved in partnering with the Superhome movement. And then we have partners who support us, and then we have participants who there's a monthly subscription for that, $500 or $1,000 for a national supply company. So the top 10 principles of a superhome, ventilation is there. The base requirement in a superhome for a certified superhome is whole home heat recovery ventilation. We don't go for anything less than that. And we have our base, better, best standards. So it's important to think about the home and everything in the home and how the home works as a system. And we really need to think about air tightness and how the home's heated and insulated, and along with ventilation. So all the details and how everything works together. So our air tightness requirements for superhomes start at 3 for base, better 2, best 1 air change. And we've recently introduced monitoring to superhomes, which has been really great. So every superhome that we finish now has monitoring installed, so we can see the temperature, relative humidity, and CO2. So we understand how the home's performing, and then we can also add to that the energy data so we understand that it's meeting the minimum requirements of a super home and what the energy is required to achieve that. So we put these sensors into the homes, they just plug into a socket, and we have an app on my phone here, and we can just monitor all of the homes, and that will be a really helpful aid for certifying the homes. So existing homes, we can just, the proof is in the pudding, we can see the actual performance instead of the predicted performance and understand where that sits. So what is proper ventilation? Just getting back to basics. So it's not what the building code leads us to believe. Opening a window, 5% of the floor area in opening window is the requirement for natural ventilation in the building code. So, natural ventilation is useful and it's a good thing, but it shouldn't be relied upon. So probably the most typical situation, condition where natural ventilation isn't really going to work is, particularly in Christchurch this time of the year, it's too cold. You don't want to open the window. And so that's not going to work. I read somewhere in a magazine an eco expert talking about how opening the window for 10 minutes a day and a peace lily would be a great thing for indoor air quality. I'm sure peace lilies, indoor plants will provide some oxygen and remove some toxins, but maybe that's not going to be adequate ventilation either. Some people, some laypersons might think that there's a heat pump there and there's a unit outside. Surely that's going to provide some ventilation. No, it's just heating. So the refrigerant lines are the only thing going to outside. There's no air coming in from outside. So that's not going to work either. This one here, I don't call this ventilation. So a bathroom fan, that's an extract. So I call that extraction. And the idea of having a vent in your windows, well, that's just bonkers. If you're putting high performance windows in, you don't want to be opening them up so cold air comes through. It's absolutely going in the reverse direction of what you're trying to achieve. So this idea of positive pressure sucking air from the ceiling, Marcus might touch on this, and then, that's just crazy. I mean, it might have worked in the past in older homes where they're really air leaky. We shouldn't be doing that as homes inherently become more airtight. It just won't work because the air it's got to escape from somewhere, otherwise that won't work. And then negative pressure, that's not going to work either. That's going to suck in contaminants through the gaps, probably from the roof space. There's a lot of nasty stuff up in there. And the biggest thing is it's just going to dump all the warm air out that you've paid to heat. So that's not a good thing either. So what we really need to move to is whole home continuous heat recovery ventilation, which we'll hear about shortly. So there's two schools of thought. You can either have the ducts in the attic space, and in that case they need to be well insulated, or as houses get more airtight, sometimes we'll have an airtight layer. So what we've been doing with these sort of homes is putting the ducts in a cavity underneath the roof truss, so that you just drop the ceiling 90 millimeters and have your ducts inside the thermal envelope. So if you can achieve that, that's going to be the best practice. So this is a house that's on this year's Superhome tour, and it's a small house that is designed to a very high standard. It's energy positive. And one thing we achieved with that was this cross ventilation by having this split level roof. You can see the top right there, the cross section. So we've got some electrically openable windows, and we can get a nice flow of air through there. So cross ventilation can be quite pleasant. It's not a bad thing. It just shouldn't be relied upon. It's probably only 10% of the time that the conditions allow for that to work. and be a good thing. So that's just the plan of that house. And the ventilation system was hidden in this spline wall that runs through the middle of the home. And so the bedroom's on one side and the living dining kitchen on the other side. There's quite a lot of stuff hidden in that wall. So that worked out quite well. And you can see that there, the ventilation system in there. So I've already talked about this. So the house, I think of the home as a system and not just how all the systems work together, the ventilation system, the solar system, the heating system, although that's really important. I think of the whole building as a system and how the building elements work as a whole. So building code, it's actually, the purpose statement of the building code is actually good. And it talks about, well, you can just read it there, it talks about providing for sustainable development and providing for a healthy internal environment for people, contribute to the health and physical independence, well-being for people who use them. So, but it just fails to deliver. So natural ventilation, I mentioned that's just not going to work most of the time. And, even talks about mechanical ventilation, but it doesn't require it. And in actual fact, G4's ventilation, G5 interior environment talks about how habitable spaces, bathroom, recreation rooms shall have provision for maintaining an internal temperature of 16 degrees C measured at 750 millimeters above floor level, while the space is adequately ventilated. Does anyone check that? No. And is there any acceptable solutions to achieve that? No. So I think the number one thing is that it's kind of the hidden, the skeleton in the closet, if you like, is health. And nothing else matters when you can't breathe. Catherine Leitner, the former CEO of Asthma New Zealand, probably people have heard this over and over, but my story after the earthquakes, my kids became ill and one developed severe asthma, and the doctor said, it's probably your house. And we were living in a rental that had rising damp and inadequate ventilation. And that's kind of what drove us to do the Superhome movement. And, there's all these terrible statistics about health. 30,000 kids get admitted to hospital each winter, and that is actually increasing year on year. I think 7% of children have asthma in New Zealand. That's about 120,000 kids. And we have the second highest rate or death rate, I think, in the world. I think it probably fluctuates year on year, but that's what I've heard. We even have the second highest occurrence of rheumatic fever. Uganda is number one. And these are preventable things preventable illnesses that we just shouldn't have, or we should definitely have in much lesser numbers. So if we all lived in healthy homes, there'd be 30% less hospital admissions. You've probably heard the statistics from the widely known research from Professor Philip Howden Chapman. $1 spent on better housing, healthy housing, saves $4 for the national health system. So these guys here, I mean, I could have got organised and run a quiz on the Zoom, but it's not the doctor. They're the ambulance at the bottom of the cliff. It's not actually the architect, who I couldn't find a Lego architect, so I photoshopped the little round glasses and the black turtleneck. It's actually the builders that are really going to have an impact on health, because 95% of homes are just built. There's not an architect involved. So this is a house that I started renovating before I finished the earthquake repairs on my house, and it was supposed to be temporary, but we ended up living in this house for 7 years because it took 9 years to get the insurance paid. one of the first things we did when we moved into this house, which was actually dry, which was underneath, which was good, we insulated under the floor, put polythene down, and then we put in a ventilation system, a moisture master balanced heat recovery ventilation system. Even though this house was hopelessly air leaky, it was about 20 air changes per hour. If you remember back, we're talking about 1 air change is the best. What that did do is it removed the condensation, dried out the house, so there was no longer condensation on the windows. It made it possible to heat it. So it wasn't just, most New Zealand homes, they're expensive to heat. Some of them are impossible to heat because they're just too damp. And it actually reduced our power bill putting ventilation into there because it was dry and it's easier to heat a dry home. So this is the home that I was talking about that was had a major earthquake repair, but we also took the opportunity to install ventilation. So where there's a will, there's a way. It's harder with renovations, but you can install ventilation if you want it bad enough. So we packed out walls, which also helped with providing additional insulation. And then on the left there, we provided a bulkhead where there was spaghetti junction with lots of ducts. There was one area in the home where we couldn't reach from where the unit was located, the whole home central unit. So we had a decentralized unit for an ensuite and 2 bedrooms in the lower level where there was steel beams in the way, and we couldn't get through that. So there's different ways you can do things, which Marcus will talk about later. So key thing is design, installation, the commissioning, the support, and the service, and just the end-to-end whole package. And it's a bit of a minefield out there. We've found a lot of people that supply equipment, sometimes great equipment, but they don't provide all of these things. And you really need to think about it from the early design stage as early as possible. And that's really important. So why ventilate? We talked about health, comfort, just having a pleasant space, which is a nice even temperature. And also energy efficiency. It's cheaper to heat a dry home, and easier and cheaper to heat. And also the building's durability, the longevity, the durability of the building, protecting the building from moisture and condensation. Because if you're not ventilating the building, there's much more likelihood of interstitial condensation and getting mold growth inside the walls or ceiling. So I'll just switch over to Marcus now, and he can talk to us about all the details.
Great, thanks, Bob. That was good. So we'll just jump straight into it, and I'll just talk through this next week presentation. There's a little bit of crossover from what Bob's just discussed, but those bits we'll run through quickly. So why ventilation matters. Just a little bit of background on who we are as Moisture Master. We're a family-run business established roughly 25 years ago. We used to fight with the big boys in terms of the standard ventilation that you hear about, those who shall not be named. And roughly 10 or 12 years ago, whilst in Europe, working with some suppliers over there, in Germany, they hit us up about actually, are we still just blowing air in from the roof space? And at that point, the answer was, well, yeah, that's what we do in New Zealand. And we then were schooled very quickly on heat recovery ventilation, and out of that came the initial designs for New Zealand homes, retrofit options, and then creating relationships with high quality suppliers out of Europe. So we offer European quality systems, custom design, supply, install, and after sales support and maintenance, filters and parts, etc. So We've briefly touched on a little bit of this. What's the problem historically? New Zealand's homes are notoriously damp, cold, drafty. This encourages mold growth and can lead to respiratory issues. The Asthma and Respiratory Foundation reports that 1 in 6 New Zealanders live with respiratory illness. That equates to roughly 700,000 people and costs the economy an estimated $5 billion annually, whether that's in healthcare, whether that's in repairing mold or cleaning mold, or it's just the fact that people are taking time off work or looking after sick children and not being able to work. Part of the issue there is that the moisture that just living puts into a home. So each occupant can contribute between 7 to 9 litres of moisture into a home a day, just by breathing, showering, cooking, drying clothes inside in front of the heat pump. So a 4-person home can run anywhere, 30 to 40 litres. And even your dehumidifier that is pulling 10, 12 litres out in a 24-hour period is still going to struggle. You're still going to have moisture going into the building fabric. A little bit of this has been covered by Bob, but what's the problem currently? Well, the New Zealand Building Code still allows for natural ventilation. And this worked for older, less airtight homes, but as we start to insulate more, everything becomes more airtight. It doesn't deal with the fact that moisture is being trapped within the home. In our opinion, the industry is lacking guidance and education on how the improving of the thermal performance of a home with insulation and airtightness actually affects the internal moisture. Like I say, that moisture ends up in the building fabric. And we see it actually in new builds a lot. People think, oh, we'll build a new home, we're not going to get moisture or condensation. The reality is that you still do. And we get calls about new builds with mold in the roof space, for instance, and that's becoming an increasing phone conversation that we're having. There are ways to solve it, but it's a lot more challenging to solve it 2 years down the line rather than during the design and build phase. So just carrying on from the current situation, so 1960, we had approximately 17 air changes per hour. This is a study that was released by Brands in 2018. So 17 air changes per hour in homes built around 1960 works out at 1 air change. So that's all of the air, all of the heat in your home being changed every 3.5 minutes. So the homes are notoriously hard to heat. Up to 2000 homes built 2010 plus, up to 2018, we were reducing that right down to approximately 5 air changes per hour on average. So that's a lot better. And we're getting to 1 air change every 12 minutes. We recently lived in a home, rented a new build home, it was 2 years old. And I'd find that I'd turn the heat pump off and I'd go and get ready for bed. And maybe 10 minutes later, 15 minutes later, I'd come out and get a glass of water, and I'd notice that the living area was a bit chilly. And that kind of attests to that air change was happening within that time. We were starting to lose heat really quickly after any heating was turned off. Superhome recommends a base of 3 air changes per hour, better of 1 or less than 1. So yeah, we've still got a wee ways to go to get there. So what's the solution? Obviously ventilation, that's what we're here talking about. There's 3 types of ventilation. Negative pressure ventilation, which is your simple bathroom extracts. Positive pressure ventilation, which is the usual in the New Zealand market. These worked in old leaky homes where you're blowing air in from the roof space and that pushes moisture out. There's various issues with both of these systems. They don't work in newer homes, or they're not recommended at all in newer homes as a solution for a performance solution. We are behind mechanical heat recovery ventilation. So, and I'll explain exactly how that works in a moment. But there is systems out there that will say, right, we're a balanced system without heat recovery, and that will tick certain boxes on other various home rating tools. But it doesn't really make sense. If you're not putting a heat exchanger on it, then it's kind of, what's the point? You're just sucking air out when you're putting air back in that's cold. So we're not really on board with those. And similarly, we're not on board with just continuous negative pressure, at least from a performance perspective. As Bob mentioned, it will just extract the heat out and it increases your demand. It does help dry the home, but as we start to get more airtight and go down the performance line, it's extracting that heat that we're doing our best to keep in the home. So heat recovery, how it works. We're extracting the moist stale air from the warm moist areas of the home, passing it through a heat exchanger. That heat exchanger holds the heat whilst sending the moisture outside. We simultaneously bring fresh air in from outside, pass it through the heat exchanger in the opposite direction. And as it passes through the heat exchanger, it picks up the heat that's been trapped or recovered, and then we distribute this to the home as fresh, pre-warmed air. So, so we're supplying and extracting in balance, and that's the key. And as soon as you're doing that, you're putting a heat exchanger on it, and we're being able to recover that heat. That we've gone to the trouble of insulating more, making things more airtightness, so we're not losing heat through the envelope. We then need to we want to recover that heat and put that into the fresh air. Systems have various other options on it. Some are bypasses, preheaters, post heaters, humidity sensors, temperature controls, things like that. But generally speaking, that's your basic system, which is what we're talking there. General benefits. So we've got health, as was mentioned, indoor air quality, remove the risk of internal moisture, pollutants, mold, contaminants. CO2 is one that I think is a little bit underrated. There's not a huge amount of research that's been done in residential environments, but we know in office environments, high levels of CO2 will reduce productivity. People get headaches, get a bit drowsy and sleepy. So, it can't be a good thing in our home overnight. When it comes to the efficiencies, so systems will recover up to 94% of outgoing heat, some of the higher end systems. And we're utilizing that kind of waste heat at ceiling level to extract and put that through the system and recover it. And as Bob alluded to, a dry home takes less energy to heat. We've also the practical things, so security, no need to open windows. Noise, as we all starting to live in closer proximity with apartments, etc. We can keep that noise down while fresh air without opening windows, and keeps the bugs out as well. It also protects the fabric of the building from that moisture, as we talked about earlier. And it's sustainable. It's in our opinion, it's the missing piece of a sustainable, efficient home. So we're going down the line of insulating, we're increasing our air tightness, we're then trapping moisture. So we want to recover that heat that gets trapped in that home and get rid of that moisture. And that's where heat recovery works. Now, so getting more into specifics on systems, there's two different types of systems. We've got centralized systems and decentralized systems. Each have some pros and cons. We generally push towards centralized systems, and there's the reasons for that we'll talk about here quickly. So a centralized system is a whole home system with ducts going into each room. Generally comes off the system into a manifold and then runs the duct out. We use a 75mm semi-rigid duct. So pros of the centralized system are a single point of maintenance. They've got larger volumes, generally higher controls, less filter changes in terms of we've just got the filter changes on the unit rather than lots of different filter changes for different fans. We've got higher levels of heat recovery. Some of the cons of a centralized system, they're a higher upfront cost. They take up more space generally, and they really should be designed in upfront. It's really hard work to try and squeeze in a centralized system to a home that hasn't had it designed in, or trying to squeeze it in after it's gone through consent down the line. Moving over to decentralized systems. So these are ductless systems. They go into individual rooms and they have a push-pull kind of functionality. So you have a one fan pushing on one side and a reciprocating fan that's pulling, and vice versa. They then swap over after a minute or so, and they go back the other way. A couple of pros and cons here is that they got a simpler installation, lower upfront cost, and there's no duct or service space required. However, they can be noisy, going a fan into every single room. There's only one filter on them, so they don't filter the external coming in. They filter as it goes into the home, but the fan itself and the exchanger itself doesn't have a filter on it. There's also creates many external penetrations. Recently, we had a look at a property that had eight different penetrations through SIPS panels around the home with decentralized fans. And it doesn't really make sense at that point. We're starting to cause lots of different penetrations. Needs to be sealed, external cowls, yeah, and more maintenance. So each fan there also needs to have a filter change on it, and there's 8 fans that can potentially have problems down the line. So we generally recommend that unless there's a specific need, can't get duct there, for instance, then we would always look at a centralized system. A few design considerations. We've got mainly the location of the unit is the first thing to think about. So I've noted there, get design advice early. So we should be working with your designer or your architect as early as possible, just to give guidance in terms of how we can get this in the building. As I mentioned, there's nothing worse than trying to squeeze it in later. But yeah, we want a central location for the unit to reduce the pressure on the duct lengths. Physical space required for the unit and the manifold. Physical access for the external ducts, soffits, going into soffits or a gable. We look at access into the service cavity where our ducts will run. Noise, we want to try and keep them away from bedrooms. And we can use silencer ducts if that's appropriate. But yeah, so keep them away from bedrooms. No system is silent. There's always some residual noise, so we want to take that into account. We need to run condensate drains to the systems, and they will obviously need an electrical connection. Some further design considerations. We've got sizing of the unit. So we're looking at a combination of things to size the unit accurately. We're looking at the volume of habitable space divided by or times by 0.35 air changes an hour. We're looking at number of occupants by 30 cubes per occupant per hour. We're looking at the extraction requirements for kitchens and bathrooms. And once we look at all of that, we then balance the system to the highest need of those. And then we include a 30 to 40%, sometimes even a little bit higher capacity within the system. So if we do need extra ventilation, then we've got it there rather than trying to skimp on it. A few other little considerations there, undercutting doors to make sure that we've got airflow between our negative and our positive spaces. The cavities for ducts. The wee picture there shows one way to do it. That's using rondos, but there's other ways to do it with timber and bulkheads, etc. So actually, how we're getting the duct in, we want these ducts to be within the insulated envelope, and then commissioning. So how will the system be commissioned and maintenance as well. So just as a guidance, we've kind of thought we'd just put some guide prices in here. Everyone always wants to know about the numbers, which is cool. So for a high performance home, a Percival certified system that goes within the internal envelope, we're looking at somewhere in the range of 10 to 20,000. That's yeah, obviously it varies depending on size of home, how long the duct runs are. The actual system that we're putting in. So that's kind of just a very broad number there. Some of your, depending on the system and the brand, etc., some systems will go above that. Some systems might be slightly lower than that, but that's just a kind of a mid-range for you. We've got non-certified roof space systems with insulated duct. These are the systems that we generally would look to go into existing homes to retrofit. The home that Bob mentioned had a system that was a non-certified system. They're never going to be as efficient in an existing home as something that's designed into a high performance home. But they still have value going into existing homes and reducing energy and making sure the space is dry. So they are still really good options. We do have some data there for where they've been monitored and in terms of what they do for CO2 levels and temperature within the homes. And then you've got decentralized system, and that's the system on we've got there, which is the Melton, and that one is an on-wall or through-wall system. It's actually got a heat exchanger in it, and yeah, but they're kind of ranging 2 to 5 depending on whether you're going just a straight through-wall system, which is the one I talked about earlier, or a Melton system, and exactly what we're trying to achieve with all of those. So they're just some kind of rough guides. We'll just quickly go on to just some international examples of where building codes are going, and then I think we'll shoot back to Bob and we'll open it up for some or have some kind of questions and answers about some more specifics. So around the world, the Western world anyway, is pushing for performance in homes. And we can see that just in Scotland, they're implementing passive house standards into building codes for 2025. Australia had the National Construction Code 2022, which included 7-star efficiency ratings, and they're proposing additional increases for up to 2025 as well. The UK Future Home Standard is including air tightness, heat recovery ventilation, triple glazing, and they're proposing going ahead from 2025 also. In New Zealand, we've obviously just run through H1, and the MBIE's website states clearly that this is an important first step for MBIE's Building for Climate Change program. So we clearly haven't finished in terms of building better quality. So look, we're going to end up this way anyway, regardless of all what we've said in terms of the health benefits and all the energy benefits and everything else. At some point, relatively soon, we will end up with code changes that is pushing towards heat recovery ventilation. So that's the kind of the end of the spiel, the push through from me. And I think we'll grab Bob back and we'll have a bit of a chat from questions and answers.
Cool. Thank you very much, Marcus.
No problem.
I've got a few questions. I'm wondering, do we have any questions online? Yeah.
Yep.
You want to take that one, Ian? Thoughts on Mitsubishi Losnay systems, which is combined with heat pump ductwork. I'm not really that familiar with the. Have you had anything to do with that?
Yeah, so the Losnay is a pretty mainstream system that works with Mitsubishi, and the general consensus from a high performance home is that they don't get we don't include the heating and the ventilation together, and the simple reason for that is that they get turned off. So the advice that we've had is that it's easy to someone turns their system off because they don't need heat anymore, but the reality is we still need that ventilation. So ventilation will be working in the background. Yeah, that's generally what's been advised. We do have some systems also that will work into a ducted heat pump system if you have to do it. And look, they will provide ventilation, but they're definitely not recommended for anything that's going towards more high performance. Anything if a more standard home is looking for ventilation, then you probably can have a look at those. And from what I hear, they do an okay job. But like I say, you run into some problems with people actually the functionality of them in terms of people turning them off and not understanding the difference between what's happening when the house is being heated by a ducted system versus what's happening with it being ventilated with a ducted system. So that's the thoughts there.
Yeah, I think there's different schools of thought, but generally people who are working in the high performance home space like to keep the heating and cooling separate from the ventilation. And I know some units combine it, but you've really got to shift a huge volume of air if you want effective cooling, and that's not what a ventilation system does. It's just a low volume continuously.
What's this question we've got there?
How does a ventilation system still maintain air tightness in a home when they break the wall?
So how does the ventilation system maintain air tightness in a home? Don't they need a break in the wall to install? So the systems are sealed. So through the external envelope penetration is sealed at that point, and then the entire system is sealed out to the ducts, and they're all got sealed with a rubber O-ring at each junction, and a click seal so that everything gets sealed together. So the system itself isn't allowing air tightness in and out or breaks in air tightness through it. So
One thing we didn't mention is if you do a whole home ventilation system, you don't require a bathroom extract because it's just continuously extracting from the wet areas, bathroom, laundry, etc. There'll probably be, in most cases, a boost, so you can increase the fan speed when there's steam, or there'll be either with a switch connected to a light or with a sensor, a humidistat that senses when there's steam.
Yeah. The word we get on that is that so the boost functionality, councils obviously like it because we're heading up to that 25 litres a second, which is the council requirement. But like I say, the word that a lot of people tell us is that after the first 6 months of being in the home, once the home's dried out, the boost function basically becomes redundant because the constant removal of moisture from a bathroom means the humidity level is already a lot lower. So when you have a shower, the moisture stays around less. It's there if you need it, obviously, but we're constantly extracting at low level anyway, so it's less.
Yes, and you're removing 2 or 3 holes in the wall where you're not getting that thermal bridge because you just don't have a fan from going to the outside from the bathroom.
And even then, the amount of bathroom fans that we see that aren't fit for purpose because they've got long lengths of duct on them that are all strangled out through the roof space, but also don't have a backdraft damper on it. So as soon as the wind blows in that direction, your air's just blowing straight down into your bathroom. So it's just something that we would avoid and put through the system.
So the next question, does ventilation space replace the extra fan in the kitchen? This is a question that I had for Marcus.
Yeah, the old range hood question.
Yeah, and how does that deal with the removal of oil, smells, gas in the house? Well, in our renovation, we put in a recirculating range hood, and we've found it doesn't really get rid of the cooking smells. So my advice would be, and I think Marcus agrees on this, get the kitchen extracted, get that stuff out. So you've got to have a hole in the wall for that, but have a really good backdraft damper so that, and it's only open for, less than an hour a day when you're cooking, So yeah, from my personal experience, recirculating doesn't work unless you're cooking a vegan salad. Once you start to fry something, that's not going to be adequate. So you've just got to get rid of that.
Yeah, I mean, there's backdraft dampers now available that are rated to various pressure zones. So when you get a blower door test to check your air tightness, you're running at 50 PA, and there's backdraft dampers available now that won't open until it hits say 60 PA, and so it's not going to affect your air tightness in that space. It closes and seals, but when your range hood goes on, it then sends it out. So there are some people who will recommend recirculating range hoods, but generally speaking, we would say don't use them just because they don't actually work.
Is it better for ducting to be in the floor or the ceiling? One house we put it in the floor where we had a CLT ceiling and a warm roof, so there was no ceiling space. So we ran ducting through the concrete floor. It's probably a lot more difficult than putting it in the ceiling, and if you've got a ceiling space, it's a lot more flexible.
Yeah, look, we generally recommend if you're designing it up front, and you've got a ground floor level system, and you're running your ducts up into a service void. Then if your designer's designed that service void properly, then that's really all you need. You're under the entella, you're not penetrating through. So we would, that's generally how we would do it. That's the most common way to do it. The ducts we use are a rigid or a semi-rigid duct, so they can go in the concrete, but yeah, generally speaking, we would put it in the service cavity that's been designed, not in the ceiling, but under the ceiling, under that insulation.
Next question, Lucas. Do you want to take that?
Which one? The top one? Would it be simpler and more cost effective to simply run bathroom extracts continuously and provide makeup, trickle vents, cable vents? Yeah, so that's what we call continuous negative pressure, and like I said, some rating systems are kind of encouraging that at the moment. Look, it'll get rid of your certain amount of your moisture, and in that sense, but it significantly increases your heat load that you need because you're sucking the heat out. So
I think I'd argue that's completely bonkers. Trickle vents and windows. We're trying to get the best possible high performance windows we can, not open up the window frames to allow air in. It does a job, but it creates another problem. And I think if you remember back to the villa that we started renovating, that actually had a different system, the positive pressure idea, where it had a fan that sucked air out of the roof space, like a lot of Kiwi homes. And that was already in there. And what it did do is it removed some moisture, but it was no way energy efficient. And so basically we put in a heat recovery ventilation system. We just turned that off and kept it switched off and turned the new one on because we realized that doesn't really work. By the time we started putting in new windows and trying to make the house more airtight, it just was not going to work because the air actually has to come from somewhere. So same with negative pressure. The air has to come from somewhere, otherwise the fan just isn't going to extract air if it's an airtight house. So the best thing is just put in a proper balanced energy recovery ventilation system. And that's where we start with a super home.
Yeah, I think a couple of things to remember is that even with heat recovery, you still need to make sure that there's enough heat in the home. You can't have a home with no heat and then expect to get heat out of it. It doesn't work. So heating is really important, and I don't think we've really touched on that. But getting an efficient heat system is really important. We generally don't recommend just the negative pressure running constantly. Look, it is a more cost efficient solution, as you've noted there, but it's, from our perspective, it's not. It doesn't really work.
Elisa, does the system use a lot of energy to run? Thinking about power bill. Well, that villa reno was an example where our power bill actually went down after installing the system because it will use a little bit of energy to run the fan, no doubt about that, but it's probably equal to a light bulb, and then it more than compensates by getting rid of the moisture so that the house is actually drier and much easier to heat. Our experience was the power bill went down even with the ventilation system running continuously because of that. And also the house was much warmer and more comfortable and healthier too. So a lot of people just think about the power bill, but the other aspect is the comfort as well as the health, but also the well-being, the mental health of not having weeping windows and actually having a home that is really lovely, livable space. Yeah,
look, just on a really kind of a practical side of things. So the systems all have two fans, either a supply fan and the extract fan on them, and they're all efficient. They have to run at less than 50 watts per fan. So you're talking 100 watts. But most systems are a lot more efficient than that. I would say that's at the higher end of what your system will cost or use from an energy perspective. So for the cost of a light bulb, it's providing a healthy home.
Lots of questions. So we had one about how do your units prevent mold from developing within the system, extracting moist air from the bathrooms, etc.?
So the systems have condensate drains on them. So if any moisture condensates within the system, then the drain will obviously drip out and through the drain. As long as there's airflow going there, you won't get mold in the system. So mold only is produced in the system when a fan stops. So if a fan stops, then moisture produces and it's allowed to sit, and then the mold will grow. But if as long as the fan is running, then you won't get moisture in the system. Also make sure that they need to be maintained. So obviously filter changes, and then you need to be able to remove the exchanger once every couple of years and clean it out properly. So yeah.
Adrian, is the system with a boost sufficient to keep the mirror steam free and the kitchen smell free? Well, probably not. So from my experience, you probably still want to have a mirror demister, a heater pad on your mirror. It'll actually make a difference. It'll make it less. But yeah, kitchen, we already talked about that. And yeah, you definitely need a extracting to the outside with the kitchen. And there's no way around that one. But yeah, I mean, you'll still have a whole home ventilation system that'll be supplying fresh air and extracting from the kitchen space. But you just need a range for that hour or so while you're cooking.
Yeah, and I think with the boost function in the bathroom, look, you do produce a lot of moisture, and bathrooms are pretty small spaces. So when you're showering, especially if you've got a couple of people showering one after another, you produce a lot of moisture there. So we would expect, because the humidity level is already lower, that the mirrors and that will demist faster. But we can't promise that your mirrors are not going to have any steam on them, because that depends on how long people are showering for, how warm the room is. There's a few other variables there, but generally they will clear faster with your heat recovery.
Yeah.
Do your systems have dehumidifier to present outside air with high levels of humidity pumping into the building? No, they don't have dehumidifiers on them. We find that the fresh air that's provided is always less than, in terms of humidity, always less inside the home, outside the home than it is inside the home. And so that crossover means that we're always providing less moisture as it comes in into the home. So yeah, no dehumidifiers. They're not something that is generally used in New Zealand. I know in some places in the States they specifically put HVAC dehumidifiers, but it's not something that we do here.
Some of these questions are getting quite detailed, and there's a lot of questions, so we might not get to all of them. But and there's one that's sort of talking about lots of different technical stuff, litres per second and things. So I'd suggest that might be a follow-up where you talk to Marcus later about some more of those details. And maybe just sit down and have a chat would be a good idea.
Yeah.
So sorry if I've brushed over that one, but definitely happy to talk about those things. Shall we keep going, Marcus? Do you want to do the next one?
Yeah. What one? So decentralized systems manage humidity, even though, so that we just briefly talked about that in terms of the external humidity versus internal humidity. So we're talking about relative humidity there. If you've got people living in the home, then it's always going to be more humid in the home, the humidity level within rather than outside. There's obviously a few variables to that, but and the systems do have the ability to have humidity sensors on them, but they become quite specific in terms of those questions there. So there are more system specific questions, so we'll bring those up later.
Are there any issues with condensation build-up in the heat recovery unit when extracting from wet areas?
Yeah, so briefly talked about that earlier in terms of as long as the fans are running, then there's no, there shouldn't be any mold or moisture build-up within the system. And any decent system that there should have a condensate drain on it if we're extracting out of wet areas, just as a baseline. So there's a specific question there about passive velocity system. We can come back to that one. I can talk to you individually about that if you like. Um, yeah, so with a retrofit option, so Ian Thrush has asked, for retrofit into an existing home, insulation is normally run on the bottom cords. Would it be beneficial to move the insulation to the top cord so that the system and the ducting is within the thermal envelope? So yeah, with a retrofit, there's two ways to do it. You can use your insulated ducting and a roof space system, or a within home system and then going into the roof space with insulated ducting. Or if we're wanting to use the smaller semi-rigid ducts, then as long as they're insulated, as long as they're within under the insulation, then we can make that work. But the key is that the ducts are insulated. Otherwise, it's a waste of time and you get moisture in the ducts. So
I think just from reading that question, it might be there's sort of two or three different ways of doing things. So, but do you have the insulation on the top cord? Maybe that's more reading between the lines. That might be more thinking about a warm roof. So you insulate the roof at the top, and then the whole cavity, the whole attic space is available to run ducts.
Sure.
That's probably a good idea. You could have the insulation below the bottom cord and have that space there where you run your ducts. You can include insulation in that space as well as the ducts. So you get an extra bit of insulation. You know, we're now requiring 6.6, or building code is calling for 6.6. You don't always require that much, but that's a space where you can get that extra insulation if you need it with a conventional roof. But
if you're not doing SIPs at the roof line, and you're wanting to use that space for ductwork and the roof space, I'm a big fan of insulating at the roof line, whether that's, like I say, SIPs or strapping insulation there, strapping it up tight. We change a lot of filters, and the amount of movement that happens with insulation in a roof space is huge. So, you know, it might be perfect at building time and building consent time, but, you know, give it a few years, whether it's an electrician comes in to change some lights or do something, there's movement and then heat loss in that insulation. So yeah, if we can do it at there, we're either insulating at the top line or we're using a SIPs panel or another type of panel to keep that insulation in place, then that works a bit better.
Yeah, so and it'll be good if your unit, your ventilation unit should be preferably in an insulated space anyway. So if it's in a cold ceiling, cold attic, it's not going to work so well.
No.
But personally, my preference is to put the units in a cupboard, so that it's easier to access to change the filters, because if it's up in the roof, people will forget about it and maybe it's too hard, they won't bother changing the filter. If it's in a cupboard, it's really easy, you just pull the filter out and put a new one in.
Yep. Yep. Are there quality backdraft dampers available to fit onto the suction side of a bathroom fan? Access to external areas can be difficult and hard to implement if you are renting. Yeah, the short answer is yes, there are backdraft dampers. There's definitely backdraft dampers and then backdraft dampers. So yeah, there are better quality ones available. There are mechanical dampers. Obviously, the cost starts to go up on that. If you're looking for a specific, just an on and off with a bathroom fan, that could be used as well. But yeah, there are manual or mechanical dampers there.
So what is the one air change recommendation based on? Well, brands recommend a minimum of 3 air changes. Passive House, it's 0.6. I think Homestar, it's Homestar 8 is 3, 9 is 2, and 10 is 1 air change. Yeah, so I mean, there's different standards out there. Different building codes around the world have different standards. I think probably New Zealand is one of the only few countries that doesn't have any standard for air tightness. Yeah, that just comes down to what your budget is and what level of performance you're wanting to target.
Yep, totally agree with that.
How much does it cost to maintain?
Sure. So with a heat recovery system that's not in the ceiling space, that's down within the home, you've got 2 filters annual filter change. So because they're not up in the roof space, it's something that's simple for a homeowner to do. So, and we'd recommend that the homeowner actually does them a lot of the time, because it means that you become familiar with how your system works, and you can pick if there's an issue or noises, etc. So you've got some filters to change annually. They're around 2 filters are going to be $150, something like that. If you had a technician come out, obviously there's a technician cost there, and then every 2 to 3 years there'll be a full service done on it, which will be $300 to $400 maybe in that zone, depending on the system. But I guess that's the way to think about it, is that if say you spent $15,000 on a system, if you spent $15,000 on a car, you'd expect to go and get it serviced and spend a wee bit of money on it each year to make sure that it's running properly.
Yeah.
So it's
yeah, and if you do design it so that it's in a cupboard, you don't need to pay someone to change the filters. You can just do that yourself, and it doesn't take up the whole cupboard space. It'll just take up the top part of the cupboard, so you can still use the rest of it for storage.
Mm-hmm. Yep.
So that, I think we've got through the questions.
And
well done.
Bang on 1 o'clock.
Pretty good. Should we high five?
I don't know.
Is that going to jinx it?
Yep.
Thank you everybody for joining in today, and we have our Superhome tours on the 20th of July. So have a look on the Superhome website for that. Have a look at the other the forthcoming webinars. This next one's on materials, where we'll be talking about everything about materials, including the embodied carbon, which is a hot topic right at the moment, which not many people seem to know about, but we're doing New Zealand's first carbon negative superhome, which is just about to start, and that'll be our next demonstration project. So we'll be talking about carbon a lot going forward. And then we have another webinar on super systems, and how everything works together with the systems within a home, heating systems and solar systems and etc.
Yeah. So yeah, I'd just say that as with Moisture Master, we're really passionate about making sure that the right system's going into the right home. So if anyone needs some advice, or wants to talk about specifics on systems or what might be possible, then don't hesitate to call us either on the 0800 number or through Superhome, and you can come directly to myself.
So just another little bit of a plug. We're doing our Superhome design guides, Super Reno guide, as well as new home design guide. If you're in the industry, which I think quite a few people who are tuning in are, then take the opportunity to connect with us, and we're doing interviews with people and be a part of that. It's a good way to get involved with the Superhome movement, but also good for your business to get some recognition and get your name out there as well. So yeah, touch base, info@superhome.co.nz. Thanks everybody. Enjoy the rest of your day.
Cheers, guys.
Bye bye.